what we have learned last time, that 8036 has 4 general purpose registers named as extended AX, extended BX, extended CX and extended DX, which can be used as 8-bit, 16-bit or 32-bit registers. Besides that, there is one particular group, what is known as index group. In index group, we have extended source index, extended destination index registers. These registers, as the name suggests, are used for some indirect type of operation. So extended SI is a further subdivided into 16-bit source index or altogether 32-bit extended source index register. Same is applicable for extended destination index register. Now, these registers can be used as 8-bit. This particular higher 16-bit part cannot be used separately. If you want to use it, it has to be used with altogether lower 16-bit part and higher 16-bit part as extended source index register. Now, besides that, we have extended stack pointer register and extended base pointer register. These are all 32-bit. Stack pointer, as the name suggests, is the register responsible for maintaining stack. So for stack manipulation, this stack pointer register is always used by the system. Base pointer, as the name suggests, is again a pointer register which is used for some indirect type of addressing. We are going to learn the addressing modes when we are conversant with the registers. So these two, extended SI and extended DI, forms the index group of register, and extended stack pointer and extended base pointer is known as the pointer group of your microprocessor registers. As I told you that your program, when it is executed, it has to be sequenced. So there is one particular register known as IP, stands for instruction pointer, that sequences the execution of the program. It is not a programmable register, it is used by the system internally, and IP is a 16-bit register when operating in real mode, and it is extended IP, which is a 32-bit register. So this instruction pointer is used for sequencing the execution of the program. Means your system decides which is the next memory address from where the instruction has to be fetched. We are going to learn how this particular address is computed later. The next section of the registers is a segment group. Let us understand briefly what is a segment. Segments are nothing but the partitions of the memory solely for partitioning the functionality. I mean, whenever there is a program is nothing but the code, but that code has to be operated on certain data, inherent or the user-defined stack operations are also possible, so that your information is divided, classified categorically into different functional blocks in the memory, and these blocks are known as segments. So it can be segment 1, it can be segment 2. In this way you may have n number of segments depending on the instance at that time and the availability of the memory. This number n varies from one instance to another. The size of the segment also depends. It is variable definitely. But how these particular segments are created is interesting to see. And for that, this particular microprocessor has 6 segment registers One is the CS, which stands for core segment, DS, which stands for data segment. Then we have ES, which stands for extra segment, SS, which stands for stack segment, and two additional segment registers known as FS and GS. All these are 16-bit registers. These registers play the role in deciding the initial address and the particular location of that particular segment in the memory. So, as the name suggests, these are classified registers for specific functionality, like CS for core, DS for data, SS for stack. Extra segment, as the name suggests, is not extra, but it can be used as data segment. FS can be used as additional data segment. GS can also be used as additional data segment. After that, we are going to learn how your system generates actual segment translated address by using the contents of segment register and contents of corresponding register that is used as offset. So we will see it next time.